All right, so today we're going to talk about deterministic mocking with GraphQL and Apollo, and I'm going to introduce you guys to a project that we call Lunar at Ezcator. And actually, I have a little doodad that I'm going to plug in so that I can not have to be in front of my computer the whole time. If it works. If I can plug it in. And wait for it. Sorry. All right, cool. So, going the wrong direction. So let's get started. So again, my name is Faga. This is my Git and my Twitter handle, and I'm an engineer over at Ezcator. At Ezcator, we focus on building front-end React apps with GraphQL backends in the Ruby world. So, by the time we're done with this presentation, I want to make sure that you guys understand what GraphQL and Apollo are. I want to introduce you to some tooling that's going to help you jumpstart your React and your Apollo projects. I'm going to show you guys how we can write deterministic unit tests with Apollo components. And then I'm going to explain the problems that Lunar, a library that Ezcator has put out into the open source community, solves and why you're going to want to use it. So, what are GraphQL and Apollo? Here you can see that I'm requesting a user ID 35, and what I'm looking to get back is some information about that user. Ideally, their ID, their name, and their eye color. And so because GraphQL is just a query language for your API, what you ask for is what you get back. Right? So here you can see the response that's yielded on the right is a data object that has a user, and that user has an ID, a name, and an eye color. In addition to querying for data, you can also use GraphQL to actually mutate data or change state on your server. And so in this mutation, we're adding a user to our system. At the top here, you can see that this mutation takes in a name and an eye color. And if you use your imaginations, there's probably a bunch of other things we're going to want to support to add our users, but here we're keeping it pretty simple. And then the response, we're again asking for an ID, a name, and an eye color back. So that's a very quick intro into what GraphQL is, but there's a ton of functionality that you get out of GraphQL. So you can do things like streaming data with GraphQL subscriptions and a bunch of other things, but we're not going to dive into a bunch of that today, but I encourage you to check out their website. And then there's Apollo. And Apollo has created a family of technologies that allow you to monitor and build applications that are powered by GraphQL. And we use their software over at Ezcator. They're really just a group of awesome people that have done a bunch of very hard things so that we can go about building our applications with a whole lot of ease. So we're going to jump into one of the tools that Apollo's put out there. It's called Apollo Server. And I'm going to dive into some live demoing. So let's dive into some code. Sorry. Not ready. Okay, can everyone see this okay, or should I blow this up a little bit? Blow it up a little bit. All right. Does that work? A little bit more? Cool. So this is a GraphQL schema. There are two types at the top of this schema. There's a query type and there's a mutation type. These are your entry points into the GraphQL API. So every type has fields, right? So if we look at this query type, we've got a users field, we've got a user field, and that user field actually takes an ID parameter and returns a type user. Right, so both of these are returning some type of user. The users is actually returning an array of user. And because these reference the user type, if we jump down to the user type, when I query the users field, I can then have access to all of the properties or the fields on type user. Right, so type user has an ID, a name, and favorite foods references a favorite food item array. And so we can continue to traverse this graph of types until we get to just the scalar types that GraphQL gives us out of the box. Things like strings, integers, IDs. So, our Apollo server. This is what it takes to spin up Apollo server. It's pretty simple. There's not a whole lot going on here. We're reading in the Apollo server constructor from their library. We're doing some things to actually read in the schema that you see here on our left. And then we're just spinning up a new server. We're passing it that schema, and we're passing it this mocks true property. And what this mocks true property does is it tells Apollo server, hey, when I query for data, I just want you to make data up. I want you to, based on the types, those scalar properties that I'm asking for back, I just want you to give me a value that is typed properly. And once we've told Apollo server to do that, all we do is start it up like any other Express server, and we're kind of up and running. And so what does that look like? This is Apollo Playground. If you've worked in the GraphQL space at all, you've probably heard of Graphical. The Apollo Playground is effectively a graphical UI that is on steroids. There's a lot of other things that are baked into this. But you can also manage things like HTTP headers. There's some tracing you can do if you want to leverage some of the Apollo engine stuff that's out there. There's a lot of tooling built into this. But long story short, we've got our query here on the left. We can dive into the schema on the right. So again, we've got queries and mutations, just as we talked about in our schema file. We've got two fields in queries. We've got users, and we've got a user that takes an ID property. And we can kind of traverse into things to figure out what sort of information is available to us until we get to an actual scalar type. One of the things that's really cool is that if I come back into my schema file, if I can learn how to type, and say I am also looking to on my user, not just, well, I noted eye color, right? So let's add eye color, and we'll say it's of type string. If I refresh my Apollo server, and I look at my schema, and we look at that user type, if I actually refresh the screen, and I look at my user type, it is not showing up, so I'm going to restart my server. And now we're going to refresh our schema. We look at our user type, you can see eye color is showing up now. Because eye color is showing up as an additional property, just by adding it to my schema, I can query for eye color. And it auto-completes because the graphical UI is super user-friendly and it's a known schema. And I can hit play here. You can see that eye color is showing up. And because it's of type string, I'm getting this hello world value back. And you'll notice that every time I hit play, some of these values are changing, right? So things that are typed ID, we're getting a bunch of UUIDs back. And every time I hit the server, the mock server is saying, oh, you want a UUID? I'm going to generate you a random value. For strings, you'll see you just get hello world back. It's nothing all that interesting. You'll see eating frequency, we're getting this monthly and weekly value back. Eating frequency is an enum, right? So for eating frequency in the schema, we've defined that it's an enum that returns a value of either daily, weekly, or monthly. So there's already a lot of power that we're getting out of Apollo server and the ability to just mock data. So what does that actually look like in an app? Well, here's my favorite foods app. This app shows me a list of users. Now, users have names, and their names are strings, and so using just the vanilla mock server, all their names are always going to be hello world. And when I dive into a user, I can see what the user's favorite foods are, and you can see this user likes to eat hello world on a weekly basis and hello world on a daily basis. And if I really like to eat donuts on a weekly basis, and I add that, like this form works, but the mock server is just returning me that same mock data back every time I interact with it. So this gets me up and running. I don't need a back-end team developing a bunch of APIs for me or building out the actual functionality. I can just tell the server to mock something for me, and I can start building my app. Right? These are React components hitting a live API. It just happens to be an API that's mocking data for me. So I can rapidly build this app without having a dependency on a team that actually has to implement the underpinnings of my backend and having those relationships. So that's pretty cool. But we can actually take this a step further. So on the left here, I'm going to open another mock server. So here, there's a subtle difference. Instead of returning mocks true, I'm just providing the Apollo server a mocks object. And I'm reading that mocks object from another file. And if we open that up, wait for it. If we open that up, you see that what mocks is defined as, it's just a JavaScript object, and it's got a few keys here. We've got a food item key, a user key. Is that feedback? Am I okay? Okay, should I? Okay. Food item, a user, and a query. And so these are actually types that are in our schema. And so if we zero in on one of these types, you see that for user, we want our mock server to have an opinion about the name field and the favorite foods field. And so for the name field, we're using the faker library in JavaScript to generate a name that looks realistic. And for the favorite foods property, we're using this thing called mock list. And mock list comes from the Apollo server toolset. And mock list has a bunch of power, but this is effectively saying, hey, I want you to return a list of 5 favorite foods. And what's really cool about mock list is it gives you a lot more power than that. You can actually pass a secondary function here that allows you to iterate over each one of those items and have an opinion about how those are actually generated. But the thing that's really cool is because I've had an opinion about my food item here, when I generate a mock list of favorite foods, it's going to look at this template when it generates that mock list of 5. So when I say, hey, when I query for users, I want 3 users back. And that mock list is going to say, okay, I'm going to use this user template that you've defined. And I'm going to give you a name that looks real, and a favorite foods, there's always going to be 5 of them. So if I actually kill the server I'm running and start the one that has mocks plugged in, and I come back to my playground, you'll see that now, as I hit the server, I'm getting some more realistic looking data. Now, name looks real, right? But eye color, I'm still getting hello world back. In my template that I defined for user, I didn't have an opinion about the eye color field. So the mock server is still doing all that work for me. But the data that I want to look realistic looks real. So I've got an eye color, and then if I actually just collapse these, you'll see that there's 5 favorite foods for this user, just as I defined in my mock list. So if we jump back into my favorite foods app, and I refresh this, there's my user list of 3. And if I jump into any one of these users, you can see there's 5 food items. And these look a little bit more realistic. I like to eat eggs Benedict, I like to eat chocolate ice cream. Now in my form, if I say I like to eat donuts on a weekly basis, that mock server still doesn't know what a donut is. It only knows what eggs Benedict is and chocolate ice cream is and peppers are. Right? So we're still getting fake data back, it's just more realistic looking. So I can get a better idea of what the UI for my app is really going to be without looking at hello world all over my app. So Apollo server is super powerful. We can really develop our apps in a very fast and iterative way. We can make changes about the schema without having dependency and actually having to have something built, which is just super powerful. So I highly recommend you check this out. This will get you up and running with an app without having to worry about any of those concerns behind the scenes in a really cool way. Any questions so far? Cool. Let's jump back in. So, what does it look like to test one of these things? So here is the user list query, or the user list component, excuse me, that we're just looking at that generates that initial page of users. Right, and here you can see the top is maybe not something I typically put in here, but this is handling the various states we can get back from GraphQL, right? So we've got a loading state, we're going to want to show some sort of loading text. There might be network errors, we're going to want to show what that error is or handle that in a different way. Then there's GraphQL errors, which you may want to handle in a slightly different way because sometimes you get partial responses back from the GraphQL API and you want to show that partial data. There's a lot of options you've got there. And then there's really like the core of the component, right? Here we're checking the number of users we got back, and if we don't have any, we display this message, and if we do, we generate that list and map it into an unordered list of user list items. So what does it look like to test this? So this is the spec file for that. Here we've just written a helper function at the top of that file that takes in some mocks, and then it calls the renderer. We're purposely using the React test renderer here. You don't need anything special to test these. At EasyCater, we actually use Enzyme. There's some examples in the repo that I'll share with everybody later that show what it's like to use Enzyme. But just for demonstrative purposes, like you don't need anything special to test these. Right, and so we're importing this mocked provider. This is really where all the magic happens. And you'll see that we're wrapping our user list component with that mock provider, and we're providing it the mocks that we're passing into our helper function. Right, and so what we're basically saying is, hey, mock provider, here are the mocks we want you to use to return back to us when you render this component. So, what does it look like to test this loading state? Well, that's pretty simple, actually. We're going to go ahead and pass an empty request for our query to the render component that's going to get mocked out, and we're just going to call component to JSON, children, join, equals loading. This is a little dirty looking because, again, we're just using React test renderer and Enzyme. You could kind of pretty this up a little bit in terms of how you get to the responsive loading. But there's not a lot going on here. Sorry. To do something a little bit more interesting, you'll see now that in addition to specifying the request, which takes the query, which is our user list query, we're also specifying a specific result that we want to receive back. And so here our result is that data object that has a user's object, which is an array that is empty. Right, so we're testing our no users yet use case in this component. And you'll notice that we're awaiting wait 0. So we plugged in the wait library, and everything in Apollo happens asynchronously. Right? And so we have to tick the clock forward to get past that loading state. And so what's kind of awkward about this is just when the component first renders, you're by default in a loading state, and I can depend on that happening. But in order to test all of the other states of our component, we actually have to tick that clock forward and have that query execute and then look at its results. And so that's what we're doing with this await wait 0. And once we've done that, you'll see that when we render that same component and look at its children and join them together, we get that string, you don't have any users yet. Right? So we've cycled the clock forward, and now the component's actually rendering something different. To test the actual display of user items, we do something super similar. Now we've got an opinion about the users that are getting returned in that data set, right? So there's 2 users getting returned here. The first has an ID of 1 with a name of Mark. The second has a D of 2 and a name of Hillary. We render the component below, we wait, and then we can see that in our user list items, we have those 2 users in our result set. Right, so we're ticking that clock forward, and then we're validating that data. What happens when you provide bad data to your mocked request? Right here, I forgot an ID property. What's nice about the mocked provider is it says, hey, there's a missing field. It's a missing field of ID in name Mark, the object that you provided. So this actually will break my test. My test will blow up. Right? So it's guaranteeing that the query that I'm actually executing matches the result set that I'm providing to the mock provider. So what's really nice about that is it guarantees that you're not testing something with your query component that isn't actually happening in real life. You have to match the schema that you've requested in your query with your mock data. If you don't, your test will break, which is one of the awesome things about using that mocked provider. One of the strategies I've seen for testing components that use queries is by actually breaking them apart, where you've got this query component that has this infrastructural concern, and then you've got this nice display component that doesn't have any infrastructural concerns, but now you no longer have that dependency on your mock provider, and you're defining the data set yourself. So if you change something about the internals of the query and you update your tests, everything's going to pass. It's going to work great. But when you actually hook it up to the query that wraps it, it's going to start breaking because you're not actually requesting a field that that component is working for. So your tests pass, but your actual production app doesn't run. So by testing them together, you actually get some benefit. there's an infrastructural concern there that feels a little dirty, but at the end of the day, I think there's more benefit of doing it this way than there is not. Testing errors is super similar. So instead of providing a data object, for network errors, we're providing this error object with the name of the error, and then we're just validating that the result we get back is that same error message, which is different, and I'm not sure why, probably because that's a bad screenshot. I think that's actually the component says whoops and renders that instead of the actual error message, sorry. I feel like I missed a slide. Oh, sorry. The top one is a network error and testing or providing a network error to the component. This bottom one is actually providing GraphQL error messages, right? Subtle difference there. Network errors you don't have a whole lot of control over. GraphQL errors are the things that you would be programming into your API to give a user information about things like, oh, sorry, you're not authenticated to access this resource, or this resource does not exist, and so you have the ability to kind of add in messages at the GraphQL error without actually blowing things up. Mutations, right? Mutations is the other side of the GraphQL world. Mutations, you're actually set up the same way. We've got a mutation component here. This is that form. This is at least the wrapper for that form, where we've got our mutation, it takes an update function, and then we render our form inside of that. Testing this is exactly the same. So we've got some variables that we're declaring at the top, and then we're declaring the mocks that we want to pass to that helper function. Right? And so here we're defining that request. It takes a query, which this time is our mutation. This is also taking some variables. It's taking a user ID, a name, and an eating frequency. What's really interesting about the mock provider is that the request that is actually being sent through your test, the variables that get sent there have to match these exactly. So you actually have the ability to test multiple mutations on a form if you want to, with different values getting passed as variables. And the mock provider knows which result set to return back to you based on the variables you provided. And if your test exercises the code without the variables that are specified in any of your mocks, again, that test will blow up because it says, hey, I don't know how to mock this. I don't know what these variables are. The result set is defined exactly the same way as you would define a result set for your query. And then the rest of your test is just any other React test renderer test that you'd write. Right, so here we're filling out the form, we're checking that some spies are called, and at the very bottom, we're checking that our success message is displayed. Any questions? Cool, you guys are easy. So, let's talk about integration tests, because those are the things that are really hard. So at ezCater, we use Cypress to run our integration tests. Their software provides a complete end-to-end testing experience. You can run your tests in two different modes, via the console in a headless Electron app, or in the actual Chrome web browser. Either way, you've got access to snapshots as you're running your tests, an easy way to chain async assertions without having to use sleep or wait. And if you're running in Chrome, you've actually got access to the full dev tool experience. So let's look at a simple integration test. Here you can see that we're visiting our local host to user 1. We're validating that the header contains some aspect of a favorite foods list. And then we're grabbing all of the list items and we're checking the length that they're equal to 5. And below you can actually see what the Cypress test that actually runs below that actually looks like in terms of output. But where's that 5 come from? That 5 is weird. Like, that seems pretty magical, right? That actually comes from our mock server. We defined that for our user type, it returns a favorite foods array of length 5. And so we've got this like weird tight coupling of our mock server to our unit test, which prevents me from really testing variations of this form and how things work, and that doesn't feel really good. So those problems, again, like coupling of our tests and our inability to test variations of components. So how do I actually fix that? So ezCater developed something called Lunar to help with this. And what Lunar does is it helps you decouple your integration tests from your mock server implementation, which is hugely powerful. Lunar gives you the ability to say, hey, I want you to return me this data, and then you run your test, and it gives you that data that you thought, or that you had staged beforehand. Looks like a lot of other testing frameworks that are out there. So, what does that actually look like? Let's dive in. I'm going to kill this. And spin up our Lunar server. The Lunar mock server looks eerily similar to the other mock servers that I've shown you already, so I'm not going to dive into those. I'm going to spin Cypress up, hopefully. And we're going to close this out. Cool, so here's our test. And I'm actually going to pull it up in Cypress so we can see it. And you see that this test is going to pass. All right, so we just ran that test in Cypress. It returned 5 items. We expected 5 items. Everything's green. We're good to go. Let's break this test. I only want there to be 2 items in this list. So if we come back to Cypress, Cypress is going to automatically rerun that. You see that now this test has actually turned red, because I'm still getting 5 items on the list. So how do I fix that? Well, we fix that by using Lunar. So we wrote in this repo just a wrapper around Lunar with Cypress that we called mock. This is really, mock is the function that's making the API call to Lunar to actually see the data. And here we're passing something that's eerily similar to the mock objects that we actually defined on our server. Right, so we've defined a query key, and the query returns a user. And then that user is actually going to return a favorite foods property. Oh, sorry. Caps lock. And you'll see that here, we want 2 favorite foods returned. Now this looks a little weird, right? We're just saying, hey, I want 2 empty objects back for favorite foods. And really all this is us saying to Lunar, hey, I want 2 favorite foods back for this user. I just don't have an opinion about the template you're going to use to generate those favorite foods. Use whatever you want. Use the mock server, use your fake data. I just want to make sure that when we call favorite foods that I get 2 objects back. All right? So if I actually save that and I jump back into my file, you see on the right, we've got 2 list items back on my screen, and you'll see that my test is passing again. Right, so we've now used Lunar to actually seed some data on the server and get that back for our test to validate what we're expecting to actually happen. Let's take that a step further. Instead of these favorite foods, let's say I want to know a little bit more information about those favorite foods. So I don't just want 2 objects back, I want 2 objects, and I want, for the first one, I want that food item to have a name of spaghetti and an eating frequency of weekly. And after the second one, I want a food item with a name of coconut water and an eating frequency of daily. And let's also go ahead and assert that data. All right, so I want to assert those things as well on my page. So if we jump back into Cypress, now you'll see that I like to eat spaghetti on a weekly basis, and I like to eat coconut water on a daily basis, and you'll see that we're asserting the length. And then we're asserting that our page actually contains both of those list items as written. Pretty cool stuff, right? We've seeded our data on the server. We've ran our tests. I have the ability by test to say, hey, I want this data back every time I execute this query. We can make sure our pages and our components are functioning the way we want to in a very integrated way in the actual web browser. Any questions on that? So let's dive into something a little bit hairier, like a mutation. So here we're going to test our actual favorite foods form. So let's take a look at what we've got. We've got a mock on our query field. There's the user. We want to return no favorite foods. And then our mutations, when we add a favorite food, we want it to return a new food item with a name of mac and cheese and an eating frequency of weekly. So we're going to navigate to the page. We're going to validate that initially there's no favorite food items yet, and that's because we're returning from our user query favorite foods of an empty array. We're going to fill in our form with mac and cheese and our eating frequency, and then we're going to click the button. We're going to validate that now there's a list item on our page that says I like to eat mac and cheese on a weekly basis. We're also going to validate that our form gets reset and that we see our success message. Let's just jump into Cypress and run that. Right, and that works. That turns green. That's pretty awesome. Like I'm able to test changes to my backend via mocking it with Lunar. But there's something, again, that doesn't feel quite right about this. Right? I'm filling out my form with mac and cheese. Then up here, I've kind of got mac and cheese hard-coded again. So what happens if instead of filling out my form with mac and cheese, I say I want a fluffernutter sandwich. Typing's hard on a daily basis because I love fluffernutter. Right? If I could jump back into Cypress, you can see I actually entered fluffernutter sandwich. But when my test is done rendering, my screen still says I like to eat mac and cheese on a weekly basis. So what's going on there? Right, so in the mock server, I kind of skipped over this earlier, so I'm going to bring it up. Mocks. When we're defining our mock server, we have full access to what's called a resolver in GraphQL. So these keys are mapping to functions, and those functions are just returning object templates. But we can do more than just return an empty object template. We've actually got access to a bunch of really interesting things that you would have access to in any GraphQL server when you're resolving the field in GraphQL. So you've got access to the parent object that actually owns that field. You've got access to the arguments that are being used to actually execute that query. You've got access to the context that's being used to execute that query. And then you've got access to a bunch of other lower level things that are for more advanced usage as a fourth parameter that, again, we're not going to get into. So we can actually take advantage of some of those things in Lunar as well, because, again, what we're mocking here uses the same exact structure of the things that we're passing to our mock server directly. So those first two things I mentioned, we've got access to the parent object and to the arguments that are being used to execute that query. And actually, I want to do that inside the resolver for add favorite food. So instead of returning mac and cheese, I'm going to return args.name. Instead of returning the eating frequency of weekly hard-coded, I'm going to return args.eating frequency. Right, and so I've removed that hard-coded data. Now I'm using the data that's actually being submitted from the form in my app. And so now if we jump back into Cypress, you'll see that I like to eat fluffernutter sandwich on a daily basis. Right, I've coupled my form directly to the response that I get back in my mutation. So I'm no longer duplicating data. And so now my test is failing, which is awesome, because I don't like to eat mac and cheese on a weekly basis. I like to eat fluffernutter sandwiches on a daily basis. So if we just fluffernutter sandwich on a daily basis, and we rerun that test, now you'll see that my test is not passing, probably because I'm bad at spelling. Or fluffin', oh boy. 2. What did I spell? Fluff. Oh, weekly daily. Yeah, that's sometimes I get really hungry, and yeah, that's right. So there we go. Am I missing something? I think we're good. What's up?
Basis at the end. You just ended with daily.
Yeah, daily. That's what I'm submitting up here, daily.
Oh yeah, should it say daily basis?
Oh, yeah, it's matching because I'm doing contains, but yes. Thank you. Yeah, so right, so that still passes. Right, so now we've got a fully functional unit test here, or not unit test, integration test that fills out a form and leverages Lunar to return the data back based on the arguments that were submitted by that form. So you're getting some really cool and powerful stuff here. So we'll jump back into here. All right, so again, like Lunar has allowed us to decouple ourselves from our mock server. And so we're no longer dependent on the templates that we've defined. This is actually some code that we wrote at ezCater in our mock server before we developed Lunar. Right? And so this is actually how we were seeding our mock server. And you'll see we're doing some crazy stuff in here. We're actually regexing the address.city property that's coming in to the, I think, to the query or to the mutation. And we're checking if the city has the word multiple in it. And if it does, we're returning this multiple payload with 2 fake addresses. And if it has the word error in it, we're returning an empty response. If it has anything else, we're just returning a successful response. That's really bad. This is how we were actually testing our GraphQL API before we had something like Lunar, where we could say, hey, this is the data I want you to return. Now I'm going to run my test and interact with it. And I can rely on that data coming back. This is what we're doing. This doesn't scale, right? Like when I tweak something in here, I want to introduce a new regex expression, I can end up breaking 30 tests just because they cared about the word multiple. Like when I'm writing my test, I shouldn't care about how other tests have an opinion about the data coming back. I should be able to have my own opinion, seed that, and then run my test and get that back. And that's what Lunar actually gets you. This is just a recap. And our minds are blown because Lunar is actually pretty badass. It did some really cool stuff, and I hope you guys check it out. And so with that, I'll say that ezCater is hiring. Again, we do a lot of really cool stuff on the React side of things. We're looking to contribute more and more on the open source side of things. React front ends, GraphQL APIs, Ruby backends. If you're interested in any of those things, probably less so the Ruby stuff because this is a React meetup. And again, my name is Mark Faga. This is my Git and my Twitter. You'll see at the top here, the repo of all the code that we actually walk through is available on my GitHub at React Boston 2018 Lunar launch. The Lunar core code is also, again, open source, so it's available for viewing and contributing. We're actively building that out right now. I'm working on a version 2 to kind of streamline the API and how we actually interact with Lunar to actually use GraphQL instead of RESTful API calls, because why would we want to use RESTful API calls when we're living in a GraphQL world? So that's all I've got for now. Do you have any questions?